Momentum, a fundamental concept in physics. Momentum is one of the most important concepts in physics because it describes the motion of objects and helps explain how they interact during collisions and other physical events. Defined as the product of an object's mass and velocity, momentum is a vector quantity, meaning it has both magnitude and direction. The concept of momentum is widely used in fields ranging from classical mechanics to astronomy and engineering. By understanding momentum, scientists and engineers can predict how objects will move and interact under different conditions. This principle not only explains everyday occurrences, such as a moving car or a bouncing ball, but also plays a critical role in advanced technologies, including space exploration, transportation, and safety systems. Momentum is calculated using the equation momentum, P, equals mass, m, times velocity, v. In the International System of Units, SI, momentum is measured in kilogram meters per second, kilogram times ms. Because momentum depends on both mass and velocity, an object with a large mass moving slowly can have the same momentum as a lighter object moving much faster. For example, a truck traveling at a moderate speed may have the same momentum as a small sports car traveling at a much higher speed. This relationship demonstrates why both mass and speed are important factors when analyzing motion. One of the most significant principles involving momentum is the law of conservation of momentum. This law states that the total momentum of a closed system remains constant as long as no external forces act upon it. In other words, momentum cannot be created or destroyed, it can only be transferred from one object to another. This principle is especially useful in understanding collisions, explosions, and other interactions between objects. Whether the collision is between two billiard balls, vehicles in a traffic accident, or celestial bodies in space, the total momentum before the event is equal to the total momentum afterward. There are two main types of collisions, elastic and inelastic. In an elastic collision, both momentum and kinetic energy are conserved. An example is the collision of two billiard balls, where they bounce apart with little loss of energy. In an inelastic collision, momentum is still conserved, but some kinetic energy is converted into other forms of energy, such as heat, sound, or deformation. A car crash is a common example of an inelastic collision because the vehicles often become damaged, absorbing energy while still conserving the total momentum of the system. Understanding these different types of collisions helps engineers design safer vehicles and protective equipment. Impulse is another important concept closely related to momentum. Impulse refers to the change in momentum of an object when a force is applied over a period of time. It is calculated using the equation impulse J equals force F times time t. According to the impulse momentum theorem, the impulse applied to an object equals its change in momentum. This relationship explains why increasing the time during which a force acts can reduce the force experienced. For example, airbags and seatbelts increase the amount of time it takes for a person to come to a stop during a collision. As a result, the force acting on the person's body is reduced, lowering the risk of injury. Similarly, gymnasts bend their knees when landing from a jump to increase the stopping time and reduce the impact force. Momentum has countless applications in everyday life. In sports, athletes use momentum to improve performance. A baseball player swings the bat to transfer momentum to the ball, while a soccer player kicks the ball with varying amounts of force to control its speed and direction. Bowlers rely on the momentum of a heavy bowling ball to knock down pins effectively. In martial arts, practitioners learn how to redirect an opponent's momentum rather than oppose it directly, making their techniques more efficient. Transportation also depends heavily on the principles of momentum. Larger vehicles such as trains and trucks have greater momentum than smaller cars when traveling at the same speed because of their greater mass. This increased momentum means they require longer distances to stop, which is why truck drivers maintain greater following distances. Engineers use momentum calculations when designing roads, bridges, and braking systems to ensure public safety. Airplanes, ships, and bicycles also rely on an understanding of momentum to optimize performance and efficiency. In the field of space exploration, momentum is essential for launching rockets and maneuvering spacecraft. Rockets operate based on the conservation of momentum. As hot gases are expelled downward at high speed from the rocket engines, the rocket gains an equal and opposite momentum that propels it upward. This principle, described by Newton's third law of motion, enables spacecraft to travel through the vacuum of space without needing air to push against. Astronauts also use momentum when moving in space, where even small pushes can produce significant motion because there is very little friction to slow them down. Momentum also plays an important role in engineering and industrial design. Engineers analyze momentum when constructing buildings that can withstand earthquakes or strong winds. Manufacturers use robotic systems that carefully control momentum to assemble products with precision and safety. In amusement parks, roller coaster designers calculate momentum to ensure that rides remain exciting while meeting strict safety standards. Even in medical science, researchers study momentum to improve protective sports equipment, prosthetic devices, and surgical tools. Historically, the study of momentum has contributed greatly to the development of modern physics. Early scientists such as Galileo Galilei investigated motion, laying the groundwork for later discoveries. Sir Isaac Newton expanded these ideas in his laws of motion, which provided the mathematical framework for understanding momentum and force. Today, momentum remains a central concept in both classical and modern physics, including quantum mechanics, where particles also possess momentum despite behaving differently from everyday objects. In conclusion, momentum is a fundamental property of moving objects that describes the relationship between mass and velocity. Its conservation allows scientists and engineers to predict the outcomes of collisions, design safer vehicles, improve sports performance, and explore outer space. Closely connected to impulse and Newton's laws of motion, momentum has practical applications in nearly every aspect of modern life. From the movement of everyday objects to the motion of planets and spacecraft, the principles of momentum provide valuable insight into how the physical world operates. As technology continues to advance, understanding momentum will remain essential for solving scientific challenges and developing innovative solutions that benefit society.